All right, and here we go to session number 4 of day 2 of the IoT and Edge Days 2021. With me on the mic, I have Kai Hudalla and Dominik Guggemos of Bosch. Just a little introduction about Kai and Dominik. Kai has been working at Bosch on solutions for different IoT applications, smart home, energy management, e-mobility, automotive, etc. Kai has been an active member in the Eclipse community, and he's been leading multiple projects within the IoT and also contributing to a good number of other projects. When speaking at conferences, and I know that he's been doing that a lot recently, his main focus is on scalable device connectivity for cloud deployments. In his free time, Kai enjoys cooking, golfing, and quality TV series, underlying quality. Moving to Dominik. Dominik is a software developer working at Bosch since 2011. During his time, he was actively developing multiple projects and products in the area of IoT. Since 5 years ago, Dominik was one of the initial contributors of the Eclipse Hono project. Since 2018, he's a committer of the Eclipse Ditto project and the lead software developer on Bosch IoT Things cloud service, which builds upon Ditto. So Dominik holds a diploma in computer science from University of Ulm, Germany. Just before I move the mic to Jens and Dominik, to Kai and Dominik, I'd like to bring to your attention that we'll be allowing 10 minutes for Q&A by the end of the session. So keep your questions till the end of the session. You can always write your questions on the right side of the screen, or click the button Ask Question, and then we'll get to your question and answers by Dominik and Kai. So till then, wish you good luck. Mic is yours, Kai.
Okay, thank you for the introduction. Hello, everybody. Dominik and I would like to tell you a little bit about how you can run a full-fledged cloud stack in your private environment. And this is probably not necessarily important to all of you guys, but if you're not prone to developing your IoT solution on a public cloud where you can take advantage of, say, Azure IoT or AWS IoT, then you can as well use the Eclipse IoT technology that we are developing in the Eclipse IoT working group and run the technology that we have there on your own. However, that comes with some requirements regarding what you have for a runtime environment and how you actually deploy. And we are talking today about a way of doing that in quite an easy way. And at the end, we will also talk a little about the contents of this stack and what it is comprised of, what projects are being used or what technology is being used, the most recent development in these projects. And then I hope that we also find the time to do a little demo of where we can really show you hands-on how easy it actually is to run such a stack and what you can then do with it. So if we're talking about an IoT stack, what are we actually talking about? This is a functional breakdown, if you will, of such a stack, what you would usually find in there, or what functionality you might want to expect and can make good use of in your application. At the lower end, you have the IoT devices, and those are usually connected to the backend in the cloud or in your application by means of arbitrary protocols that these devices speak. There are several, a lot actually. Some of the more prominent ones are shown here. You might then want to be able to report or to publish telemetry data from the devices to the backend. You might want to use this telemetry data to update a digital twin that you have for the device, representing its current or latest known state. You also want to be able to send commands to the devices in order to control them, in order to update their configuration or switch states or something like that. the digital twin layer should usually provide you with an API that you can use to interact with your things individually, maybe preferably using an HTTP-based or JSON-based API. And on top of that, you also would probably want to be able to roll out software to these devices. In particular, you need to be able to update its firmware in case you have some bugs to fix or new functionality to add. And rolling out the software preferably would mean that you are able to define rollout campaigns where you can group the devices into groups of similar devices or by geolocation or stuff like that. And on top of that, then you can then focus on your business logic in your solution and take advantage of all the functionality provided by this IoT stack. So luckily, in the Eclipse IoT working group, we have been working on quite a lot of this functionality, and it maps quite easily to three of the projects that Dominik and I and some more of my colleagues are involved. At the lower level, that is Eclipse Hono at the device connectivity layer. In the middle layer, where the digital twin is maintained, that is Eclipse Ditto. And for rolling out software, we have the Eclipse hawkBit project. So this already looks quite complicated or complex in terms of there will probably be a lot of software artifacts involved implementing all this functionality, and that is true. And deploying all of this is not really trivial unless you have the right tool at hand. And this is what we try to do with the Eclipse IoT packages. The packages that we provide there are basically Helm charts, which we can use to deploy a combination of Eclipse IoT projects or other projects artifacts to Kubernetes or OpenShift using Helm. And by doing so, it becomes quite easy to deploy a complex stack like shown before with just a single command on the command line. And that is what I will demonstrate later on in the demo as well. But the overall idea, again, of the Eclipse IoT packages is to provide such Helm charts for these projects. And the initial package that we have created there is the Cloud to Edge package, which comes as no surprise, actually. And it also already contains part of this IoT stack. So it already contains a pre-configured combination of Horno and Ditto, which interact with each other or are connected to each other over AMQP 1.0. It comes with a set of protocol adapters, which you see at the bottom of the Eclipse Hono layer. It is able to connect devices via HTTP, MQTT, AMQP 1.0, LoRa, and CoAP. And however, pre-configured configuration that we use in the demo will also be like this here. On the Ditto layer, you have all these APIs or endpoints available to the solution that you can see here as well. And the package itself comes pre-configured with a demo device that is provisioned into the system so that you can immediately start playing around with it. And that is the overall idea of it, that you can get started playing around with the technology very quickly without having to set up and configure each of the components individually. But that is something that you'll see later on in the demo. So before we go there, we take a look at the components that are in the package, starting with Eclipse Hono. Horno provides a uniform API to interact with devices using all of these protocols. So I told you already about that. And what it in particular does is it provides means to send a lot of telemetry data to solutions and to interact with the devices using command and control APIs. Doing so, it is a little opinionated about the volume of data being involved. And the overall assumption is that the telemetry direction, meaning the data that is reported by things to the cloud, will be by orders of magnitude larger than the amount of the data volume that is sent in the other direction. So this is represented by the different size of these arrows here. The telemetry direction is usually optimized for throughput and needs to scale out with a number of messages, but it is not necessarily a requirement that each and every message reaches its destination. Because, for example, if you have a temperature sensor that reports the current temperature every 5 seconds, then it is not really a problem if you miss out on 1 or 2 of those messages once in a while, because you can easily extrapolate or interpolate the missing values there. However, the other direction, command and control, is usually optimized for reliability and needs to scale out with the number of devices. However, you rather seldomly send commands to devices because you do not usually switch them through cycles all the time or update their configuration all the time. So in the past, in Horno, we always supported forwarding data from devices on the left-hand side to the application on the right-hand side via an AMQP messaging network. This is basically a combination of a message router and a message broker, which uses the AMQP 1.0 protocol for exchanging messages with the other components. So in our example here, a radiator on the lower left would connect to the MQTT protocol adapter of Horno, which would then forward the data published by the radiator device via the AMQP messaging network to the air conditioning application, where it can then be processed. Since Horno 1.7, which we published, I think, 2 months ago, we added the possibility to use a Kafka cluster for forwarding the telemetry messages to the downstream applications. So this is an alternative to the AMQP messaging network, but you can also use them in parallel, actually. But the question, of course, is why would you want to do that? Why is it important to do that? The main reason we introduced that was because we wanted to better support scaling message consumption on the application side. If you have a lot of devices and they publish data, then you might need to be able to have multiple message consumers in your application on the right-hand side. And while you can do that with the AMQP messaging network by means of simply concurrently consume the messages from the topics or the addresses, that means that you might consume the messages out of order. And that is something that Kafka adds to the picture, where Kafka comes in by means of the partitioning of topics based on a partitioning key, which in our case is usually the device identifier. You can make sure that you can consume all the messages in parallel with multiple consumers while still being sure that messages that have been originating from one device will always be consumed in the correct order on the right-hand side. So this is a property of scale out that we added with adding the Kafka support, which is kind of important for many of our use cases. With this, I will hand over to Dominik, who will tell you now a little bit more about Eclipse Ditto.
Yeah, thank you, Kai. Yeah, I want to give you a short introduction to Eclipse Ditto and also give you an update of the recently released version 2.0 of Ditto, what's new and what's updated. So let's start with the introduction. As you've seen in the stack, in the IoT stack that Kai showed before, Ditto is in the layer of the digital twin, and this is the main purpose of Eclipse Ditto, to manage your digital twin, or to the digital representation of real physical devices. You can also think of it as that it mirrors your physical devices by providing a uniform API to the data, and uniform in the sense that it doesn't matter how the device is connected or which protocol it uses or which type of device it is. The representation in Ditto is normalized to a generic JSON representation, which you can then access via the APIs on the top, the HTTP or WebSocket APIs, and you can use this data in your web application or mobile application. Yeah, and what's also part of Ditto is the access control. You can define a very fine-grained access control if you like to down to the level of a single sensor value, if you want. And yeah, that's also part of it. And it's not only possible to actively request this data, but you can also subscribe for changes via WebSocket, for example, or via one of the other protocols, MQP or even Kafka, and further process updates from the devices, for example. You could use this in the UI where you want to update the UI if the device state changes, or you could even push the data into analytics software or some other backend application that further processes the data. And of course, this is the direction from the bottom, from the devices to the top. But you can also interact directly with your devices by sending messages and receiving responses from your devices. So Ditto, in combination with Hono, acts as a kind of a broker for communicating with your devices. And yeah, it abstracts away the different protocols and what you don't have to care about this anymore. And yeah, due to this flexibility and you can use Ditto in different IoT scenarios, for example, in industrial or even customer-centric use cases. Okay, yeah, that was the really short introduction, and I want to continue with what changed in the latest Ditto 2.0. Yeah, first of all, why did we make a new major version? Well, the last major version 1.0 was over 1 year ago. I think it was in the late 2019, and yeah, there was quite some deprecated code, and we want to get rid of the API version 1. So this was why we decided for the next major version. And we took this opportunity also to restructure some internals. We clean up the Ditto Maven module structure to ease further development. I think we aligned it more for the functional approach, what the Maven modules are for. So I think it's easier to maintain. And there were also some non-functional enhancements. First is the improvement of stability during rolling updates. So we tuned some parameters to make the rolling update more smooth. To reduce downtime in case of updates or deployments. We also added a sharding concept for the internal Ditto PubSub. This helps us mainly to allow multiple or a large amount of concurrent WebSocket sessions in this case. To support this when many clients connect at the same time. This should be now not anymore a problem. And further improvement in the background cleanup, which is the background cleanup is running periodically, and it imposes quite some load on the database used. And we distributed this load more equally, so this should not affect the overall performance anymore. Okay, next slide, please. And we also had some functional enhancements. One big thing was the merge functionality. In the past, that was not possible to merge with a single request the device data. So if you made an update at a certain level of your thing, and it was an override, you override all the data at this level. And now you can also do a merge update, and it will merge with the existing data. So this should make it more easier to make smaller messages to reduce the overall bandwidth. Another topic was the expiring policy subjects. So you can now define a lifetime for subjects that you add to a policy. So when this lifetime is reached, then the policy subject is deleted. And this was a requirement for the policy actions we introduced. This is very, very powerful. For example, you can do, with the policy actions, you can dynamically add subjects to your policy based on the information that's in the JSON Web Token. And the JSON Web Token is always has also an expiry date, and this is therefore used in this expiry policy subjects. It's a very powerful feature. Another small addition is the built-in acknowledgement for search updates. Ditto also provides a search, so you can search your things via the properties or attributes. And before this built-in acknowledgement, it could happen that you create or update a thing, and if you search for this thing with the updated data, it could happen that you couldn't find the thing immediately because the search is eventually consistent. And now you can specify in your requests in the search, in the create or the update requests, that you want to delay the response until the search is also updated. And this should help in these cases where you rely on the search immediately after you make a request. Then a more technical point is the establishment of connections via an SSH tunnel. This may be used in cases when your MQTT server, for example, is not accessible directly, but only via an SSH connection. So you can instruct Ditto to establish this connection, this SSH tunnel for you, and communicate over this tunnel with your MQTT server. Next one is the configurable claim extraction from the tokens OpenID connector OAuth 2. So before it was very limited or fixed what was extracted from these tokens, but now you can configure in Ditto which claims are extracted. And another connection topic is the prioritized recovery. So after restart or deployment, or maybe even after a crash, we recover all connections established to external system, and we do not do this all at once because this would overload our own services. So we have a rate limiting there, and you can now prioritize some connections over the others, which are more important or have to be started earlier. And one other small issue was for MQTT connections, you can now specify the last will and retain flags for outgoing messages. And finally, a very small thing, but it was asked quite often in the community also. The modern browsers still, it's not possible to define or to provide HTTP headers in WebSocket requests, and we now allow the JWT token as a query parameter, so you can also use the WebSocket endpoint with a JSON Web Token. That's it for our new features. And I think back to Kai.
Great, thank you, Dominik. And now we're going over to the demo part. I think we have enough time for it. I will quickly start the deployment of the Cloud2Head package to my local Minikube cluster. For that, I'll need to switch to the terminal here. And I have prepared a command that you can run. And it's, as I promised, it's just a single single command that can be used. It's Helm install, and then we tell it to deploy the Cloud to Edge package using the C2E name. And I will start this now, and in the background it will deploy it to the cluster now. This will probably take about 1 or 2 minutes. While we do so, I go back here and tell you a little bit about the demo setup that we use. And as introduced before, you can see the two layers of the Cloud to Edge package, Horno and Ditto, and this is what comes pre-configured. This is what I'm currently deploying to my Minikube cluster. And what we will do in the demo is we will simulate 2 devices, which you can see at the bottom, a temperature sensor and a humidity sensor. One of them connecting via HTTP, using Horno's HTTP adapter, and the other connecting via Horno's MQTT adapter. And what we will do is we will publish data or updates of the twin, of the digital twin, via these adapters. And the messages will then be forwarded via the AMQP 1.0 messaging network into Ditto, where Ditto will then use the data in these messages to update its local representation of the sensors. And then we will have a small application, which is just a simple JavaScript-based weather station, which includes 2 gauges, which simply show the current temperature and the current humidity. But this will basically be enough in order to showcase how you can actually use this stuff. Let's go back to the console and see how we fare. Okay. There it is. Okay, so this is the message that the pods are already installed and up and running. You can take a look here. So you see, these are the services, the individual pods that are actually being deployed. And as you can see, it's quite a handful. It's actually 2 handfuls or 3 handfuls. And all of this is deployed and pre-configured, integrated with each other simply by the Cloud to Edge package. So we don't need to bother about that. So the first thing we need to do is set some environment variables. We need to initialize them so that we have some environment variables which point to the IP address and the ports of these individual services, the external services that we want to interact with. So let's do that there, and let's do it here. So we have 2 terminals ready to be used. So the first thing is now to see what the current thing representation actually looks like. So as I told you, the package comes pre-configured with a demo device, and the demo device has a thing ID, which you can see here. So the tenant that it belongs to is the C2E package, and the device's identifier is the demo device. And what it has an attribute, a location attribute, which indicates that it is located in Germany. And what it has as a state is represented by the features that it has. And in this particular case, it has one feature called weather station, which has 2 properties called temperature and humidity. And they are both initialized with null currently. So there is no real value there currently. So what I will now do is I will initialize or open up the application that we want to use. And for that, I need to figure out the Ditto API endpoint, which I just did. I'll now open the application in the browser and feed it in here and connect to the Ditto WebSocket. So you currently don't see anything because there has not been any update message which could have been forwarded to this JavaScript application. So in order to trigger the display of the data, we will now set the initial temperature and humidity of the weather station by means of a simple HTTP post to Horno's HTTP adapter. So what it does, it authenticates to the adapter with the device ID and the secret, and then it posts some data, which is some JSON that contains the initial values of the weather station. And as soon as I do that, you can see here in the background that the gauges show up with these initial values. So we can now simply have the simulate the devices by means of some shell scripts that I can use. And I have prepared 2 shell scripts. One is using the MQTT adapter and is publishing data to the MQTT adapter, which is updating the I think the temperature. The temperature. Let's take a look. No, the humidity, and we run that in this terminal. So you can see that the values are being updated with arbitrary values. These are picked randomly, and every 2 seconds, the script publishes a new value. And in parallel to that, I can start another device sensor, which is using the HTTP adapter in order to update the values of the temperature, and that is what you can see here. So now we have these gauges representing these updated values all the time, and yeah, the data, as I told you before, flows in via Horno's protocol adapters, is then processed by Ditto to update the local twin representation, and then over the WebSocket connection to this application running in the browser, where the values are then displayed. So this can go on for as long as we want. I will stop this now because I also wanted to show you how you can use the whole system to send a command to the device itself. And for that, we will use Ditto's Thing API, the REST-based Thing API, and we will send a command to the MQTT-based humidity sensor. So I will now stop these 2 gauges here. And here at the bottom, I will now subscribe to commands on the MQTT adapter. So this is basically simply using the Mosquito subscribe tool, command line tool. Again, we connect to the Horno MQTT adapter with the username and the secret of the device, and we are subscribing to this topic here, to the command topic, with QoS 0 in this case. So this is now subscribed. And what we can now do is use Ditto's northbound Thing API to post some JSON. And in this case, the data is shown here. It is just a JSON structure with temperature scale minimum and temperature scale maximum value. And we post this to the Thing API, in particular to our demo device's inbox, where we send a message that we call recalibrate. When we do that, we see at the bottom that the message is being consumed by the MQTT device via the subscribe topic. And in here, you see the message name, recalibrate, which is the command name, and the value, which contains the 2 values. And that is about all that I wanted to show in the demo. I think it was pretty quick. You can see you can quickly spin up the whole stack in under 2 minutes in this case. That is, of course, if you have already downloaded the images, but once you have done that, you can immediately start playing around with it. And with that, I think we are at the end. And we now have enough time, I guess, for some questions, if there are any.
Yeah, absolutely. Thank you so much, Kai, Dominik, for the amazing presentation. And of course, a special shout to Kai for the demo. I think it's highly appreciated for the folks around to see it in practice. I have a few questions to ask from Shant. So Shant is asking, so when using the stack which comprises of Ditto, is there a need to use Eclipse Hono for device description? And if so, can there be a dynamic description when adding or revolving or removing the IoT devices to and from the complete stack?
That's probably a question for you, Dominik.
Yeah. Well, no, you don't have to use the Eclipse Hono. You can the JSON representation of your thing is completely free form, so you can define the structure on your own. Yeah, we have you can there's a field in the thing called the definition where you can place such a reference to a model, but this doesn't have to be a auto definition, but of course it can be.
Great, thank you. So just a follow-up question as well from Shant. He's saying that in one of the slides, there's an MQTT adapter from Horno and Mosquito, and the Mosquito broker connected to Horno 2. What's the difference between the adapter and the connection to the Mosquito broker?
That's probably this slide here.
Yeah.
Yep.
Yeah, that's simply that Ditto does not only can connect to Horno, can not only use Horno, but you can also connect MQTT directly. But yeah, that's the only difference.
Okay, so direct connection. Great, thank you, Dominik. So
the overall point here is that you should also be able to use Ditto without Horno. Yeah. And if you do so, then you can still connect devices via MQTT using an MQTT broker, for example. That's the whole idea behind it.
Okay, sounds great. Another question from my colleague Frederick Debian. He's asking, is the cloud to edge package retrieving specific versions of Ditto, hawkBit, and Horno, or does it pull the latest?
I'm sorry, I think I didn't quite understand the question. Can you repeat that?
So the question is the cloud to edge package retrieving, does it retrieve specific versions of Ditto, hawkBit, and Horno, or does it pull the latest version or the latest update?
Yeah, so as with every Helm chart, it defines some versions that it wants to pull in, but you can also override these versions. However, when you do so, you are a little on your own. So the overall idea is to always showcase the latest and greatest, but you can also modify that by means of a values YAML file where you can set the particular versions that you want to use. But as I said, you're kind of on thin ice then sometimes, in particular if there have been some configuration changes between the versions that you want to use and the version that we originally pulled in the chart. But that's absolutely possible.
Yeah, sounds great. So, but as you said, you're pretty much on your own. So, having said that, I think we're coming to the end of a great session by Bosch. Again, if there is any specific questions or queries that you would like to ask Kai or Dominik, I guess Slack would be the ultimate way to reach the folks on. Other than that, the presentation, of course, would be available for after event on Eclipse YouTube channel. So feel free to refer back to it. So another question from Shant. So what is the roadmap of cloud to edge going further? Like, how is the roadmap going to look like for cloud to edge?
So we originally also wanted to include hawkBit in the package and integrate it with Ditto in a reasonable way. However, there is some substantial work that would need to be done in order to do so. And quite frankly, we currently do not have the time or find the time doing that. So unless there is any specific demand or offer to help, I don't think that this will happen anytime soon. Apart from that, we currently mainly focus on keeping the package up to date with the latest Horno and Ditto versions. So the next thing that we want to integrate from a Horno perspective is, of course, being able to support Kafka as an alternative to the AMQP messaging network. We will probably do that once we have released Horno 1.9.0, which is due maybe in summer, I would say. But I don't know. Do you want to add something to that, Dominik? Do you have any particular plans?
No, but yeah, Ditto must also support the Kafka
Oh yeah, exactly.
connections at first. Yeah.
So
But we
Ditto
are working on this currently.
Ditto currently can only publish messages to Kafka, but it cannot consume messages from Horno via Kafka, and that is something that the colleagues are working on. And once that is available, we'll of course put it into the Cloud Stack package as well.
Perfect. Great. So yeah, he's asking if just a follow-up note, if you can get the repo of the Helm charts.
I'm sorry?
Shanti's just following up with the question if you can get the repo of the Helm charts. And I think
you mean the URL, or what do you want?
Yeah, I think, Shanti, if you're referring to the presentation. Oh, okay, here you go. Okay, thanks, Frederick. Thank you.
So it should be simple. Yeah, you simply find the Eclipse IoT Packages project, simple Google for Eclipse IoT Packages, and then on the homepage you find all the information, how to add the repo to your local Helm and how to install everything. It's all described there.
Okay. Yeah, link has been provided. Great, thank you. So just before we wrap up, I just want to bring to your attention that the next session, it's going to be another very interesting session with Arlen Nipper from Serious Link to speak innovation and Sparkplug. He'll be joined as well with Pugal Janakariman from Amazon. So again, stay tuned for this session. Very interesting, talks about leveraging Eclipse Sparkplug to accelerate data ops and machine modeling into AWS services. Stay tuned for that. I'm going to give you about 10 to 15 minutes just to stretch a little bit and drink some water before we jump into the next session. Thank you, and speak soon. Thank you, Dominik. Thank you, Kai.